lesson is simple pendulum. First of all, what is a simple pendulum? A simple pendulum consists of a single metallic isolated bob suspended from an inextensible string. Look at this diagram. Here is a simple pendulum, and when we disturb it from its mean position and take it on the other side and release there, it will start oscillating about this mean position. So we say that it performs vibratory motion. Is motion of pendulum a simple harmonic or not? Let us see. When we disturb the bob of pendulum from its mean position and when we take it to its extreme position, students, here two forces are acting on the bob. One is its weight that is acting directly downward, pull of the earth, and second is the tension in the string that is acting along the string. Now when we release the bob here, which force brings it back towards the mean position? In other words, what is the elastic restoring force in this case? Actually, students, it is the component of its weight that brings it back towards the mean position. Now if theta is the angle which this string makes with its initial equilibrium position, then we resolve its weight in two components. One is called mg cos theta. Mg is weight of the bob. Weight is the force. So this force W or mg cos theta, it is the component of weight that is acting along the string. And the next component is mg sin theta, which is perpendicular to this mg cos theta. So students, when we release it here, this component mg cos theta brings it back towards the mean position. So when it reaches at the mean position, due to inertia, it does not stop, and as a result continue to oscillate about this mean position. The student, only restoring force acting on the bob of pendulum when it oscillates is F equals to W sin theta, means the component of its weight that is acting perpendicular to the string. That is the force which is oscillating this pendulum bob. Now from Newton's second law of motion, we know that F equals to ma and W equals to mg, where g is the acceleration due to gravity. Putting these values on the places of F and W, we get equation ma equals to mg sin theta. M will be cancelled on both sides and we are left with this equation, a equals to g sin theta. Now again, from trigonometry, you know that sin theta is the ratio of perpendicular to hypotenuse of a triangle. Here is a right angle triangle OPQ, in which we consider side PQRX as a perpendicular and side PO as a hypotenuse. So sin theta will be the ratio of x over L, where L is the length of the string and x is the shortest distance between mean and extreme position of the bob. So replacing sin theta with x by L, we get a equals to gx by L. Students, since g and L are constants, g is the acceleration due to gravity and L is the length of the bob, and we assumed that it is an inextensible string, so length does not change. These two are constants, so we can say that acceleration is directly proportional to the displacement. That is the first condition of simple harmonic motion, that if acceleration of a vibrating body is directly proportional to its displacement and if it is directed towards its mean position. Now as we know that when the bob is moving towards the mean position, it speeds up, and while moving away from the mean position, it slows down. So we can say that its motion is directed towards the mean position. Therefore, we represent this situation with a negative sign. And hence, here it is the required equation for acceleration of a body that is performing simple harmonic motion. That is, a is proportional to minus x. So we can say that motion of bob of the pendulum is a simple harmonic motion. Now if it is a simple harmonic motion, now what will be the values of different terms for simple harmonic motion, and in case of simple pendulum, what will be the value of its time period? Students, here we will take the help of circular motion. From circular motion, the acceleration is related with displacement for a particle that is moving with angular velocity omega. Omega is the angular velocity. Then a equals to minus omega square x, or replacing omega with 2 pi by t. Actually it was 2 pi f, and we know that f is equals to 1 by t. So we get the equation a equals to minus 4 pi square over t square into x. 4 pi square over t square is the value of omega square. So for circular motion, acceleration is related with displacement through time period by this equation. And similarly, for simple pendulum, acceleration is equals to minus g by L into x. Since these two equations are representing acceleration, therefore comparing these two relations, we get equation like this: value of acceleration in case of simple pendulum, value of acceleration in case of circular motion. Now if we look at these equations, these on both sides of this equation, negative will be cancelled with negative sign, x will be cancelled with x. So we are left with g by L equals to 4 pi square over t square. Now students, rearranging this equation, t square equals to 4 pi square L by g. Taking root on both sides, square will be cancelled with the root, and we are left with t equals to 2 pi under root L by g. Students, it is the equation for time period of simple pendulum. Since 2 pi and g both are constants, so we concluded that time period is directly proportional to under root length. Time period of simple pendulum depends on length only. It does not depend upon the mass of the bob. Changing the length will change the time period. These two values are constant. So it is the relation for time period of simple pendulum. Now students, what will be the frequency of simple pendulum? You know, frequency is the number of vibrations completed in 1 second. Means how much vibrations a simple pendulum completes in 1 second. You know, frequency is the reciprocal of time period. We will put the value of time period that we just calculated in this equation, and we will get the value for frequency. Putting this value t equals to 2 pi under root L by g, it is the value of time period for simple pendulum. We will insert this value in this equation, and we will get the value for frequency of simple pendulum. F equals to 1 over 2 pi under root g by L. It is the equation for frequency of simple pendulum. Now students, at the end, there is another word that we use in this context is second pendulum. Student, it is a pendulum that completes one vibration in 2 seconds. In other words, a pendulum with time period 2 seconds is called a second pendulum, and its frequency according to this relation will be 1 divided by 2 equals to 0.5. Its frequency will be 0.5 hertz. What is the unit of frequency? Hertz or cycle per second. So students, this is all about simple pendulum. I hope it is clear. Students, thank you for sparing your time to watch the video. Take care of you. Goodbye.